So let's talk about making accurate and efficient decisions using if-else structures. We've already talked about planning if-else and how to write the pseudocode and how to plan for things. But let's talk about how to make accurate and efficient decisions. First off, this is a range check, right? And the range check basically checks if something is in a certain range. And you can see that this particular structure doesn't work because we are testing high limit, then medium limit, then low limit. And what happens is if it's greater than or equal to the high limit, we give it the high rate, but the high limit's also higher than the medium limit, which is also, well, it's higher than it's not lower than the low limit, but it will give you the medium rate commission because it's both higher than the high limit and higher than the low limit. So this particular if statement, when you walk through a variable and code trace it, will not work. A range check checks within if this if statement falls within a particular range. Java programmers commonly place each else of a subsequent if on the same line. And within a nested if-else statement, it is most efficient to ask the most likely question first and avoid asking the same questions. Avoid asking multiple questions, right? And you want to start by asking a question that is most likely to be true and then use else statements to pull the rest out. So you can see how we fix that range check by asking about the low limit first, most likely to be true, and then we use an else to control the rest. You can pause the video here if you want to look at that code. But this avoids asking multiple questions and makes the sequence of decisions much more efficient. Now there's a couple of errors that beginner programmers make a lot. Often they use the AND operator when they meant to use OR. For example, if you have a pay rate that is less than 0.65 and more than 60, that's not possible, so it's never going to return a true. We should use an OR operator instead. And sometimes a beginner programmer might use an ampersand, a single ampersand, or a single pipe to indicate logical AND or OR. Single ampersand and single pipes are bitwise operators, and they will not work for conditional checks. An alternative to a long string of if statements is a switch case. A switch case statement starts the structure, then it's followed by a test expression. It has a case, and there's a break at the end of each case, and there's a final default that acts as a final else. This is an example of a switch case statement. We pass in the year. If the year is 1, then that student's a freshman. We break. If we do not add a break, it'll say freshman, sophomore, right? So the break exits out of this completely. It withdraws from the switch. But case 1, case 2, case 3, case 4. Otherwise, the else statement captures all other possible values, and it's going to say invalid year. As mentioned, break statements in the switch structure are very important. If a break statement's omitted, then the program finds a match for the test variable, and all statements within the switch will execute after the match is found. The case statement, you don't have to write code for each case, and it can evaluate car values. But when it evaluates car values, it ignores whether it is uppercase or lowercase. Why do we use switches? Sometimes they're more convenient and they might look cleaner than using a long string of else's, if-else's. You don't want to use it for a couple of if-else's. It's when it gets really long that a switch case would be helpful.